Okay, today we're going to deal with the exterior angles inside a triangle, which is completely different than the interior angles of a triangle. So I want you to draw the following diagram on your block note. Okay, hopefully you had a chance to take it out. So I just want you to draw this diagram right here. We're going to label these sides A, B, C, and we're going to put a D over here. Okay. Now, angle A is an inside angle. So if I draw an angle right here, that's an inside angle because it's on the inside of the triangle. However, if I go outside to this angle, angle C actually has an inside and an outside angle. So you can see how that'd be confusing if I just say find angle C, because angle C has two options, either on the inside or the outside. So in order to label angle C, which is the one I'm looking for right here, the one that I just drew, you need to make sure that that letter is in the middle. Okay, so you're going to put the B over here, and then you could put the D on that side. This means that it's angle C because C is in the middle. So if I say BCD, I know that that's angle C for the one that I'm actually looking for. Now that angle there is on the outside of the triangle. Okay, we're just going to write that, which means that it's an exterior angle. It's not on the inside, and it doesn't work the same. So we're going to have to know a couple things before we start working with this. Also in your block note right here, I want you to write the supplementary angle theorem. Okay, I know it's a lot of words, but just write supplementary theorem. And what that means is if you have a straight line, and you have two angles. That means that that angle plus that angle equals 180. So as I just said, the little star plus the little circle is going to equal to 180. So I need that to be in your block note because that supplementary theorem is going to show up quite a bit. You're going to need to use that to find some interior angles, but also to find some exterior angles, which is on the outside. So really, really important for you to know where the angles are and what they represent. So let's do a couple of examples. These can go directly onto your block note as well. I'm going to get you to draw the following diagram. Okay, so just go ahead and draw this as best as you can. And we're going to write down a couple angles in here. These are given. You don't need to find these. Okay. There we go. And what we're going to do, I'd like you to find the measure of angle A. So we need a couple of letters here. So here's A, here's B, and here's C. Okay. So angle A can be represented by really two angles. It could be the 135, or it can be the little angle on the inside right here. So let's put a little star. So let's represent that with the A in the middle, and then we're going to start at B, and might as well go to C. Angle BAC represents this angle right here. Okay. So if we're trying to find angle BAC, we have to look for the flat line from here to here. Okay, I'm going to draw that with a different color just so you can see it. Sometimes the supplementary angle theorem is not easy to see, but if it's a flat line and you're missing part of that angle, you can use that theorem to find the rest, the portion that you're looking for. So what we're going to do here is we know that a supplementary angle is 180. So we're going to take away the angle that we do know. So if we do that, we know that 180 minus 135 is equal to 45 degrees, which means, therefore, the little star equals 45 degrees, or you can say, therefore, angle BAC equals 45 degrees. Okay? So this is an example of where you have to use the supplementary angle theorem. Now, there's another example that we're going to do together. This time I'm going to give you some angles on the outside. This one's a bit easier to draw. So let's do, it's very similar actually. Okay, like that. We're going to put an X over here. We're going to put 110 degrees over here. and we're going to put 125 over here. Now, for this example, these are all exterior angles. So it's very, very difficult for you to use the 180. You can't use the 180 because it's not an inside angle. So what you need to know, we're going to fill out this part before we complete this, this example, is that the interior and, oh, that's not right. Just scratch out interior. The exterior angles of any polygon. Now, a polygon could be any shape, so a triangle, a square, a rectangle, a five-sided shape, which is a polygon. We'll see more of that tomorrow. But right now, you need to know that all the exterior angles of a polygon equal 360. So it's not 180, it equals 360. So we can do the same process as we did yesterday, and we can add up these two angles and then subtract it from 360, or you can just do 360 minus what you're given. But this is where you have to kind of memorize that the exterior angles, the ones on the outside of the triangle, are equal to 360 if you add them all up. So if you do that work, you get that angle is equal to 125 degrees. So x is equal to 125 degrees. I'm going to do it the other way, just so you can see it. So if I add up 110 plus 125, so if you don't know what to do, I would just add them up no matter what. And then you can see here that that's already more than 180. So that might help you remember that you take 360 and you subtract it from 235. So when you do that, you should get the same answer, okay? Because it's the same idea, it's just a different method. So in the end, we're just going to write, therefore, x equals 125 degrees. Okay, so this is for angles that are on the inside and on the outside. Now, Miss is going to give you the practice questions. Make sure that you write down your therefore statements at all times. Make sure you work together, but stay quiet so that you could get these questions completed.